Thank you everyone for coming, and thanks Rami for that presentation. I'm going to approach mine a little bit more general than usual. I don't have as many book references as you. There are a lot there, but I do have a few quotes and references. But yeah, a bit about myself. I'm obviously, as was mentioned before, have a broad range of experience. I am pretty much a hands-off modeller now due to what I do, but I do have a lot of modellers that work for me and a strong team. I enjoy working with them and some of them are very extremely clever modellers. But I also enjoy challenging them on their inputs and their assumptions and their recommendations. I always ask them a simple question: what does it all mean? Because certainly they plug the answer out of a computer or out of a model and tell me what it means, but really ask them, what does it mean? Because understanding what it all means is probably the most important. So a bit about today. I'm just going to cover a few areas. A brief discussion on why we model. I think that lies the question as to what we use, the type of models that are available. I'm going to have a little bit of a chat about transport data, and then I'm going to share some of my experiences and try and answer the question as to whether or not modellers are smarter than modellers. I'm not going to talk about detailed standards and calibration validation, and I'm not going to get into too much detail for modelling. So why do we undertake transport models? There are a range of reasons that we undertake the transport modelling. We try to understand what the broader impacts of policy might be. We try to understand whether or not a strategy can change behaviour or demand or travel patterns. Do we want to understand whether land use changes will result in additional traffic? And then getting down to some more level detail, does the proximity of a new access point change or have implications to the transport network? What will the changes of an intersection configuration be? So in terms of understanding the why, we've got to understand what a transport model is. So this is from the Transport for London guidelines, and it's pretty clear in terms of what they think of a transport model. But it's important to note that regardless of what the transport model is and what it's used for, it's always going to be wrong. And the question is how wrong that model is. And it's our responsibility as practitioners and modellers to understand that and then to articulate that. And I think Rami also mentioned that in his presentation. VicRoads guidelines have recently come out for operational models. And they indicate that transport models are used to explore traffic and transport planning and operational requirements over the short to long-term horizons, and can involve investigations into the structure of the transport network, etc., etc. There's a long discussion in terms of what transport models are in these guidelines, and if you do have some time, I recommend you have a look at it. In terms of understanding why, the Australian Transport Assessment and Planning guidelines also provide a bit of a breakdown and some guidance onto the reasons why we model, whether it be land use, strategic transport modelling, scenario modelling, specific project modelling, or more detailed operational modelling. As you can see, there's a clear relationship between the geographic coverage and the breadth and depth of input required. It's also important to understand where we are in the project life cycle to understand what level of effort is required, and that's really important. If we're obviously early in the optioneering stage and the strategic planning stage, then we might not need the same amount of rigour as we would for the constructability or detailed design of a particular scheme. But certainly the most important element is really trying to understand what's the question we're trying to solve with the transport models. Is it a question about traffic demand? Is it a question about a network? Is it a question about an isolated issue? What are the possible solutions? Models can be very powerful and they can provide an input into this process, but certainly understanding the question that we're trying to answer will go a long way in determining what tools we have available. Before we get into the tools, I would like to just cover transport data because I think it's important. And you've probably all heard the saying that a model is only as good as the data. But understanding the data is also really important to how strong or robust a model can be. Data does influence an outcome or a recommendation on the model. However, I do like to phrase the use of data around, again, the need and even particularly the location of where we're looking or investigating into. So for an example, having data for a growth area, if we're planning a network that's a greenfield site for the next 30 years, having good existing conditions data might not be as relevant as it might be. So this is a bit of a table that's tried to summarise the different levels of modelling and the different data types that might be available. It's a generic summary, but I do find it quite useful as a guide for when you're scoping or delivering a model. But it is funny that we do have, our data is generally binary, but the way we try and classify how much data we need is generally not. Expected, useful, potentially, they're words that are a bit vague, but what it does show is it does put the onus back on the practitioner, and the practitioner needs to make strong decisions or smart decisions around the level of data that is required. There are other factors that do come into this, including cost, time, and again, the location of where a model might be. One thing I did want to touch on, and it really probably linked to Sidra and Rami, but it does cover signal control. So the influence that signal control and operation can have on the outcome of a model shouldn't be underestimated, but I have often seen it underestimated. I've got a colleague that works with me, and he's had over 40 years experience, 25 of them in at Vic Roads, in at the Signal Control Centre. I always ask all of my modellers to sit down with Frank, and if everyone doesn't know who he is, his name's Frank. Sit down and ask him to provide a strong answer to the question they're asking, and I call it Frank's back of the envelope test. And Frank's able to provide some input into a solution, the theory of why we're proposing a phasing arrangement, or a theory as to why Sidra or another model is giving us a particular output, and making sure that it makes sense. but he's able to provide an answer pretty quickly as to whether or not the saturation flows make sense, whether the green times are accurate or make sense, and then other elements like theoretical capacities for single right turns and double right turns at an intersection. And it comes back to me, to the question I asked before, what does it all mean? So, in terms of software packages, I'm just going to cover this really briefly. We like to think, or I like to think our company is software agnostic. And what that means from an information technology context, it refers to something that is generalised and that it's applicable to various systems. We, as a consultancy that has offices all around Australia, we have a number of packages, and again, they cover a broad spectrum of detail. They cover a broad spectrum of geographical coverage, and they also cover a broad spectrum of platforms. And this figure here obviously provides a really broad overview of where the different types of models sit and the level of detail, level of effort that are required. This is another graph, another figure that we've prepared that tries to, I guess, classify or provide a guidance on where particular platforms may sit. And this is our view. There may be some variations in this, but one of the things I do find funny in my experience is that the parochialism that we have in this country and with states. So every state pretty much has a preference for a particular type of software, particularly in the microsimulation, mesoscopic area, and even macroscopic area. So, for example, in Victoria, for operational models, we use the PTV suite, and that's a preference of Vic Roads or the Department of Transport. New South Wales have a stronger preference for AIMSUN, and Queensland is has a bit of both. And then from a strategic modelling level, Cube is the software preference in Victoria, whereas in New South Wales it's EMI, and other states vary around Australia. Again, it can be a challenge, but it demonstrates the need that a lot of the information that goes into these models are very generic from a sense that they should be transferable, and it's up to the modeller to understand the inputs and then process the outputs. How much time do I have? Is anyone recording? 5 minutes? Okay, all right, thank you. Well, I'll run through some project examples pretty quickly, and they're not. I'm not going to talk about the model per se, and I touched on the data, but one thing I'm going to talk through is a model that we developed in Geelong, and it's not. I'm not going to talk about the model per se. It's how we started to use the data to develop the demands that we used in the models. And this included a range of data sources. And the idea of going through these data sources was not just to put it directly into the platform, into the software, and get an answer, was for us to think about all the data that's going into it before we actually run the model, before we actually get some outputs from it. So we used off-street parking, then we looked at all the levels of on-street parking, and we had a lot of data with that. And so we're able to look at the utilisation of each of those data and really understand where within the central area of Geelong people were travelling to. We didn't know where they were travelling from, but we were able to add a few more steps into the process. So we're able to develop zones, obviously, we call them centroids. Then we matched a lot of the parking areas with the centroids. Then we imported, obviously, demands to and from the model, which was done in AIMSUN in this instance. But we also referenced the statewide strategic model, and we created a greater structure in terms of not only the model, but certainly where the demands were travelling to and from. And then we were able to refine that in a little bit more detail. What we're able to do as part of that, we were then able to obviously provide a pretty robust model, and then we were able to assess options, and in this case it was for some bus routes and some changes to the configuration of the network within the city. Another example was, and this probably comes to the heart of why we use models, and coming back to the question of are they smarter than modelers. So this is a series, a few layers of what a model can provide in terms of its output. So what this map shows is a combination of the land use inputs, where growth might occur, and changes to traffic congestion. And this is taken from the Victorian Integrated Transport Model. It's a strategic model and a statewide model. So the red lines show the links that reduce in speed as a result of growth. I think it's up to 2031. And the blue lines show the changes in land use that will occur at that same time. There's a lot of information here within just this plot and picture that we're trying to show, but then the question is, what does it all mean? And that's the question I come back to at the start. And so, but what we were able to do from that was then use that information to help inform and develop a strategy for the western suburbs. In this case, it was for Sunshine. And so what that clearly meant, that it's not just about the model results, it's not just about what the model's telling us, it's about how we can use it to inform a decision, and in this case, a strategy. The final quick example, well, I've got a couple of examples, is we often do use multi-layers of models to assess them. So we can use a range of software platforms. In this case, we used the Victorian Integrated Transport Model. We developed a mesoscopic model. I think this was for one of the level crossings. But we also used Sidra. And the Sidra was a really valuable input in helping us refine and optimise the signal control within the model. And then some platforms are obviously easier to integrate, and this is Visum and Visim, which is the PTV software. So just to finish, I did ask myself the question at the start of this at the start of preparing this presentation: are good decisions made from models, or do models make good decisions? And my answer to that is transport models are becoming more sophisticated. They are tools that can help inform the impact of a proposal or a scheme, but understanding the problem is critical to determining the right response. But still, there is no substitute for common sense. So in answer to that question, I still think the models are helping people, engineers, practitioners make strong decisions, but they're not giving us the answer, all the answer. Thank you.